So this is a video for problem set 5, number 5, 11.1.19, and we're looking at a survey that was given in 1945 versus a survey that was given in current day, and comparing those two proportions. So first of all, to get your values in letter A, all you're doing is we have here those that said they were total abstainers, what percentage each one was. So your sample proportion is just, which one said they were abstainers in 1945 and which one said they were abstainers in the recent survey. So to find that, all you're going to do is take these numbers here. So in the first one, it said that 418 indicated that they were total abstainers right here. So we're going to go ahead and divide 418 by 1100. And if you just do that in your calculator, which I did over here, 418 divided by 1100, I got 0.38. And that's what they got here as well. Now they are rounding to 3 decimal places, so even though we only had 2, we're going to add a 0. You'll do the same thing for the recent survey, which was 396 divided by 1100, and you'll get 0.360. Now these are your 3 requirements in order to be able to run your hypothesis test for a proportion. And if you go to your book, I just go to the question help over here that you can actually go through. If you click through this question help is great because it gives you all of your kind of book that you would have in this context of this particular problem. These are your 3 things that you need when you do an experiment for a change in proportion. So we're just clicking those off. The samples have to be independent. Okay, that's here on letter F. The sample size has to be less than 5% of the population for each sample, so that's there. And you have to have this whole n times p hat times 1 minus p hat has to be greater than or equal to 10 for both samples. So you do want to calculate that to make sure that's true. This whole sample size, less than 5% of the population. I mean, adults, 1,100 adults is definitely less than 5% of the entire population of adults. So definitely that's going to be true. Now when you go ahead and determine your null and alternative hypothesis, remember that your null hypothesis is always an equal sign. Your alternative is going to depend on what they say. Are they saying that it's less than, greater than, or just not equal to? And here they were just saying, has it changed? They're not saying is it less, they're not saying is it more. Has it changed is going to be the not equal to symbol. Now you can run this hypothesis right in StatCrunch. So you're going to open it in StatCrunch here, and I had already run it just to make sure I had everything correct. So you'll go to Stat, Proportion Stats, 2 samples, and you're doing with a summary because they're giving you how many successes and the total. So our successes for the first one, I'm just going to pull this down, was 418, and that was out of 1100. And then your proportion for the second one was 396. And again, that was out of 1100. And again, my first symbol here is equal, my second symbol here is not equal. And we'll click compute. And you can see our z statistic, which is our proportion here, is 0.97, and your p-value, they're running to 3 decimal places, is 0.331, which is what they got over here. Okay. Now the whole idea of your p-value. So the p-value, and again, it's probably easier to explain this if you go into view an example. I'm just going to click through to show you kind of how you interpret p-value. This is what it would give you in the book as well, but it's kind of easier to read just to have me kind of show you here. So this is just going through all of the values here. Okay. So interpreting the p-value. A p-value is the probability of observing a sample statistic as extreme or more extreme than the one observed under the assumption that the statement in the null hypothesis is true. So you may want to read that a couple times. I know that's a lot. So a p-value is the probability of observing a sample statistic as extreme or more extreme than the one observed under the assumption that the statement in the null hypothesis is true. So when we go here, right, if the population proportions are equal, this is your null hypothesis, equal, right? One would expect a sample difference to be greater than the absolute value, again, greater than, about 33 out of 100. So the way they're getting that is this is 0.331, which is about 33 hundredths. They're just kind of ignoring the 1 here. So always state the null hypothesis, which is going to be equal. We want it to be greater than, because we get more extreme. Okay, and then 33 out of 100 is just this p-value as a value here, 33 hundredths. So because our P is lower than alpha, alpha was 0.01, if the P is low, the null must go. So we do not reject the null because this is not lower than alpha. So we do not reject H naught. Now we have two different choices here, and the key is what your claim was. We want to know had it changed. And in this case, because we're not rejecting H naught, we're not rejecting this whole equal sign could be true. There's no evidence to say that it is not true, that they actually have changed. So there's not sufficient evidence to suggest that the proportion of adults who totally abstain from alcohol has changed. So let me know if you need any more help on this, and I hope that that helps.